Hello, Godot users. Wizard of Westmarch here with something a little different. Normally, I'm giving tutorials about specific tools the engine provides, like the navigation system or collisions. This is taking a slightly different approach. Today, we're talking about thinking about ways you can use a tool that might not cross your mind. I'm calling it an inspirational. This one is about shaders. More specifically, it is about using shaders to spice up your user interface. When I see people talking about shaders, it is normally spicing up the character or a filter over the entire camera, creating an effect like Breath of the Wild, etc. You can probably use shaders more places than you think, and should always be considering how they can improve your presentation. A simple example of using shaders on the UI is creating an interesting animation effect, which I'll show off one version of it using noise textures as an example of the effect going on right now on your screen. This is not meant to be a real introduction to shaders, though I'll take some time to explain a few concepts so you can Google answers more easily. In the future, I might make a real series about shaders, but I'll need to get far better with them before I'm comfortable doing that. For now, I hope to inspire you to experiment with using shaders in more places than you might have otherwise. Before we continue, I want to show you one of the problems I ran into and why I don't think of this as a true tutorial. You'll notice here I have a hidden progress bar. Let's show it and hide the texture progress bar. You'll notice that past the halfway point, it is animating similar to the first half. The thing is, the shader should not be covering that far into the progress bar. I haven't figured out why, but it appears as if the shader on a progress bar treats the on and off parts of the progress bar as separate textures and runs over both of them, which is probably undesirable behavior. With that out of the way, let's look at creating an interesting shader effect on the texture progress bar. Okay, so now that we've talked about some of the issues I ran into and caveats, let's actually talk about applying the shader. First, a little bit about progress bars and specifically the texture progress bar. The way it works is you have three images, or well, any kind of texture really, that you put. So the under is the baseline that is visible for anything that is not the value. So, like if you have perfect health and you've got a health bar, you would see none of this. If you're at one health, 99% of your health bar would be this. The over is something you put over the top. So, like if you have some beautification that you're doing that's static or, technically be affected by the shader potentially. And then progress is the part that actually represents the progress itself. So once again, if your progress bar should be perfect, like you have max health, then it's going to cover the whole thing. If you're dead, it will be empty. Range covers the idea of, so min value is like in this case, it starts at 0. Step is the increment size. So like if you're actually wanting floats, you might put this at 0.1 or 0.01, however you want to do it. Value is the current value, so you'll usually be setting that in code. So like in this case, we have a max of 100, it's currently 70, so 70% of the progress bar is filled up. So those are the basics that matter. Now we're going to go into the material. You'll notice it's under canvas item. So everything that has canvas item has a shader available. When you're creating them, I'll go ahead temporarily remove the shader. What you would normally do is new shader material, and then you would do new shader. And at this point, you are filling in either a shader, which is the text-based, similar to GLSL or HLSL, etc. But Godot does have its own shader language, so if you go look at something like Book of Shaders, it's not going to help until you learn how to transliterate between the two. We're going to be using shader for the examples because that's what I've been learning lately. In this case, I'm going to quick load just so we've got the example already ready. Shader parameters I'll go into when we get in the code, but these are things that I have put as available to be set. Actually, we'll go over one of them now. So you need a noise texture to make this work. These are super useful. So I made a noise texture, and then you come down here to noise, and then I made it fast line noise. And you will notice like there's different algorithms. Once we get everything set up, it will have different values. Actually, let's go ahead and make that actually start to work. So you'll see Simple X Smoothest, Simple X, Perlin. So like each of these is creating a noticeably different effect. One thing, if you're going to do scrolling like I am here, you want to turn on seamless so that it expressly designs the noise so that when you're scrolling, it will work correctly. But these are all things that you can do to tune it. I would say play with the shader material from the noise because it can do all kinds of stuff for you. Now that that's done, let's actually look at the underlying shader code. Okay, so let's open this up. So I clicked on it, and you will notice it opens a new text editor, kind of similar to what you've seen before with the regular GD script code, but it is in the bottom window instead of being a replacement for the viewport. And you have your list of files, and these are just this looks more like C than like Python, so it is very different and takes some getting used to. The first line of your shader will always be a shader type because we're doing 2D, it's a canvas item. If I was doing a 3D object, it would be, I believe it's spatial. There's a few others, but for now, they don't matter. Whenever you want to make something available as a shader parameter, like we see over here where we have the color modification, etc., you put it as a uniform. Sampler 2D means it's an image. So that is why for the noise text, I had the option of creating the noise image or all that stuff. Also note this repeat enable is why the scrolling that we're going to go into more detail on works and why I had to turn seamless on. Color modifier and progress are just floats because I want them to be settable here. There are two reasons that you will want uniforms for this kind of work. Well, more than two really, but the two related to what I'm about to talk about are, one, you want to be able to tune it without recompiling the shader. So you just sit there and can type the value in the UI similar to all the stuff you've done before where it's like, oh, I want to try out like maybe it's speed 50, maybe it's speed 70. You can sit there and tune it without updating code. This is the same with the uniforms, and it can be very useful. The other thing is, if it's a uniform, you can update it in code. We won't go over that today. You can look it up, but there is an option to set parameter or something like that on shaders. Now, when you want to change colors, it is always void fragment. It's void vertex if you're doing 3D stuff, or well, technically you can do it with 2D as well. But if you're altering vertices and the physical structure, then it's a vertex function. You will notice here that I am creating a vector 2, and by the way, you will notice that you have to type everything, and you have to end with a semicolon. If I remove the semicolon, the shader breaks. You'll notice it goes to blue, and it immediately goes red. Complains about the next line because just like GD script, frankly, the parser is not great. And then this next line, we are grabbing the color at this specific pixel. UV is basically getting the coordinates, and texture is the texture that the shader is attached to. So this is a way of getting the color at a specific coordinate. Final color equal original color, just so we can override it. Then we grab a similar thing where I'm grabbing from the noise text this UV plus offset times time. Note, time is a built-in for the shader language that just says, give me the time. It rolls every 3,600 seconds by default. So basically what we're doing here is saying, okay, so I am moving the UV by this 0.2 per second. So it's just methodically moving along, which is why this continues to scroll. And then here is where I was talking about the progress stuff. Basically, because it's a float 0 to 1, because UV is 0 to 1 on the X and 0 to 1 on the Y, I don't remember why they switched it to U and V instead of being X and Y for coordinates and shaders, but they did. So we are grabbing the UV's X, and once again, it's really silly that you can call it UV.X when it's UV, but anyway. So I'm saying if the UV is less than the progress, then we are updating based on this noise color of the noise color minus the color modifier, which was another uniform up above. We're updating both the B and the G. And then if it's within a certain range of the modifier, so positive and negative 0.2, then we're setting it to solid white. So what that does, if we come up here, you'll notice it's creating bands around at the edges of where the major color change is. This is just a handy trick, and it's much cheaper than some of the other things you can do, as far as I know, to look for the color band. But this just makes it where it's very pretty. And then we update so color is the actual color at the coordinate. You know, it's the equivalent of this texture comma UV. So we are replacing the existing color with whatever we calculated, and color will just equal color if UV progress is greater than that. So like in this example, you would basically divide your value by max to say, okay, so I'm at 70%, so past 0.7 to get it covering the right portion. And then once you do that, you'll notice the left part is scrolling and the right part is not, because this right part is greater than, it's the last 30%, and therefore it is not scrolling because the shader is not bothering to run it against all of this code. This creates really cool effects. You could use multiple UV textures if you wanted to, and you could even take two UV textures, overlay them against each other, scroll them separately, and creates a lot of different effects. And it makes the UI look a lot cooler. There are obviously a bazillion things you can do. If your creativity can come up with an idea, and then you can figure out the math to make it work. And also, there is a Godot shader website where people post shaders. Double check the license if you're going to use it in your own game, but as long as it's MIT or something, you should be good. But yeah, shaders can make things look so much cooler. And if you're not thinking about it for your UI, you're missing out on a huge opportunity. So to show just a little bit more before we close out, so like let's switch this progress to 0.5. You'll notice now it is just the color of the image. And if we change it to 0.8, you'll notice it starts impacting in the underlying section, which is why you need it to match the percentage of the value. So it's one extra thing you'll have to update if you do this, but it will add a lot to the UI look. So yeah, that's the basic concept of being able to use shaders in your system, and particularly the idea of adding them to your UI. You'll notice by upping the frequency, I have made it much more detailed. This might be more computationally expensive on the GPU, you'd have to check. And that's always something you have to keep in mind, that shaders do take time. Mind you, anything on the screen is basically some kind of shader, whether it's just displaying the UV at the color of a texture or a raw color. Like if you've ever messed with Blender, there's basically just an automatic shader that generates that gray color. So yeah, because I learned watching the Cherno's videos. If you don't know him, he talks C++ and game engines a lot. But yeah, if you write like OpenGL code, you have to create a shader or at best, your GPU will use a default one. But you're always running some kind of shader, so don't let the idea of a shader taking time make you too afraid. But if you're making something more complicated, like I'd have to check what this is doing in a profiler. But this is a tool to add some pizzazz and make your UI less lifeless and far more interesting. As usual, if you have any questions, please feel free to comment and I'll try to answer or make a video. And if I do, and it's a long form video, I'll credit you. If you have any general questions about Godot that would fit the kind of videos I make, feel free to ask. And if I do, I will credit you for that as well. Just in general, the goal of this channel is to help people with game dev. You know, like I might expand at some point into more topics around like solo game dev, but for now it's just Godot. And hopefully you found this useful, and I hope you have a great day.